Good afternoon to all. Sorry for the delay. Today I was busy in many other work and just it take time to start the streaming also because there was some another work was going on. So I'm sorry. So let us start without wasting time. What we are going to study today. In the last class, we were talking about the so-called the uh, resonance phenomena. Okay, so I will today deal with the resonance phenomena only. Okay, let me search out where is that. Yeah. Okay, so in the last class, we have talked about. One minute. Okay, I was talking about the some terms related to the resonance phenomena in a series circuit. Okay, so what we are talking about that what are the half power frequency, what is the resonance condition. In fact, resonance condition, the misnomer is that in terms of electrical circuit it is being considered where voltage or current is maximum. No, it is not there. The power is maximum. We are mainly concerned with power, and they assume that the gain or the power which you have obtained will remain constant. Gain which we have obtained that will remain constant at half power frequency also. So we define this difference between the two half power frequency as the bandwidth, and we have calculated also, and this come out to be R by L. So it is very clear that the bandwidth is very much depend upon the parameters, that is the resistor and the inductor, their value which is being chosen in the circuit. So this beta is nothing but a frequency only, difference of two frequencies, but it depends upon the two parameter R and L, where R is the numerator, L is the denominator. That I have already clearly. So in order that the bandwidth should be high, okay, that more range should be there of the frequency. R should be high and L should be minimum. Okay, but generally we go for this type of resonance circuits in case of electronic circuit. So you will ask, sir, when R will be high, losses will be more, but the in losses in case of electronic circuit, they are very minimum. Hence we can eliminate this point, and therefore we increase the resistance. Okay, what is the current response curve? The current response is very similar in nature with respect to power. The only difference is that at the initial point, the current is 0, and later it rises, okay, and then it again reaches to a peak value, okay, and then it falls. Okay, so here the resonance is not in terms of current, the resonance is in terms of power. Mind it, keep in mind. Okay, though by chance we found that the current is also maximum because the impedance is minimum. Okay, so you can see. So in case of the half power frequency, current from current point of view, it will be a maximum current divided by root 2. So 1 upon root 2 is also written as 0.770. So if you want to indicate where is the half power frequency is lying, find out the I max upon root 2. That is Vm by R upon root 2 or 0.707. So these are the 2 points corresponding to the half power frequency. So you find out, so from current response curve also you can find out the bandwidth by taking the difference of the two frequencies which are present at the 1 upon root 2 times the maximum current. Voltage response, and you will surprised to know that the voltage has this has the same curve as that of the current, and again you can find out the half power frequency, that is omega 2 and omega 1, and the resonance frequency will also occur at the maximum value of the voltage, and thereby from voltage, power and current you can find out all the three things. Now there is another called quality factor. This quality factor is just inverse of the so-called bandwidth. Okay, so you will see quality factor is defined as, in fact, the resonance frequency, the resonant angular frequency divided by the bandwidth. So it is the ratio of the resonance frequency upon the bandwidth. Okay. So in fact, what this quality factor represents, this quality factor represents the sharpness of the curve. The more will be the sharp curve, okay, the more will be the output you will obtain. Okay, so more quality things you will obtain. But if it is more flat, sharp means in Hindi I can say तीखा. कर्व जितना तीखा होगा, ठीक है, उतना ही उसकी क्वालिटी बढ़िया होगी, और कर्व जितना फ्लैट होगा ऊपर से, इज इट क्लियर? तो उसका क्वालिटी पुअर होगा। तो फ्लैट होगा तो डेफिनेटली उसकी बैंडविड्थ ज्यादा होगी। शार्प होगा, तीखा तीखा टाइप का कर्व होगा, जैसा कि आप देख सकते हैं मेरा हाथ को, तीखा टाइप का कर्व होगा तो उसकी जो रेंज ऑफ फ्रीक्वेंसी वो कम होगी। तो naturally by practical consideration also we can infer that quality factor and the bandwidth are in inverse relationship. More will be the bandwidth, less will be the quality. Okay, and less will be the bandwidth, more will be the quality. The more quality means more sharp will be the curve. Okay, so when it is a high Q, when I say high Q means the quality factor is greater than 10. If omega naught upon beta comes out to be greater than or equal to 10, then we say it is a high Q circuit. Okay. And in that case, you will surprised to know that the half power frequency omega and omega 2 are very near to the power frequencies. Okay, that is, they are not widespread, and approximately they can be approximated to omega naught minus beta by 2, and omega 2 is omega naught plus beta by 2. One is by plus sign and the by minus sign. So they are very close to the resonance frequency. They are not spreading. When the circuit is high. So quality factor is one important parameter in addition to the bandwidth. Now, sorry, you can see from these three curves. Now this curve, okay, see my arrow, or I should annotate it. Now, yes, please put yourself. Bhavya Lohar, please mute yourself. Bhavya Lohar. Okay, so now you can see three curves are there in front of you. One is the very, very flat. Now this is the third curve. This is very flat. This is also flat, but less in comparison to this third one. This is second curve. Okay, and this is the sharpest curve from among these three curves. So this sharp curve, that is number one, will have more quality but less bandwidth. Okay, you can see this bandwidth. This is the half power frequency. Okay, so its bandwidth is very, very small. Now, second one is mediocre between the sharp and the wide band. Okay, so it's so-called the bandwidth is lying here, this and these 2 points. Now the third one, which is very flat at the resonance frequency, you can see this third one. Its bandwidth due to frequency f1 and f2 are very at a large distance, and his bandwidth will be more. Okay, so more will be the flat, high will be the bandwidth, but less will be the quality. But more will be the sharp, more quality it will possess, but less bandwidth it possess. So a compromise has to be made by the design engineer between the quality factor and the bandwidth. So higher value of Q, smaller the bandwidth, and there is another word called selectivity. Higher the selectivity. Generally, select means you have to choose something. So we generally choose for quality things. Okay, if I give you Lenovo, you have a choice to select two mobiles. Two mobiles are in front of you, and you have a choice to select from either of the one. You have one is a Lenovo mobile, and another is an Apple mobile. Okay, which will you choose? Please in the chat box. Okay, you have been given a choice. Okay, oh, definitely. Divyat say iPhone, very good. What about the others? What is the choice of the others? Keshav, Apple. Oh, very good. Alkit, Apple. Very good. Very good. Okay. Garvesh is saying Lenovo. Android. Tanisha, Apple. Very good. Very good. Very good. Very good. So the reason behind Apple is that no doubt Apple is costly. Okay. But because of its quality. Okay. Because of its quality. In fact, you compare the Lenovo 12 MP camera with the Apple 12 MP camera, there is a, though the parameter is same, the value is same, but the specific the quality of the Apple camera is much better in comparison to Lenovo or Samsung or anything. So if you want to go for quality, definitely quality means selectivity. Quality, in fact, refers to selectivity also. So we want a resonance circuit which is more having more quality factor. Okay, so quality means sharp curve. Sharp curve means we will go high selectivity is there with the sharp curve. So higher the value of Q, higher the selectivity, but bandwidth will be small. You have to make a compromise with the bandwidth. On the end, the lower the value of Q, larger will the bandwidth, but selective will be also lower. So this graph is very important. It can be asked in your objective type questions. And today I want to inform you that a news is there. Okay. From the dean seated to the head of department, and then head of department has passed to us that probably your midterm will start from 5th November. So get ready. I think so there will be MCQ type question through Google form. So get ready. Okay. So this is the information from my side that very soon you are going to have a midterm exam through this. So I think so selectivity concept is clear. Then how much power is dissipated by an average power being dissipated by RL circuit? We know that average power is nothing but half I square R, and that is at a resonance frequency. So we are concerned with the resonance frequency, and the maximum power dissipated resonance where I is equal to Vm by R is also equal to half Vm square upon 2R. Okay, so this is the some power calculations. Now, at certain frequency where omega is equal to omega 1 and omega 2, the dissipate power is half of the maximum power that we have already talked about. And what is the value of this? That is half P max. And P is nothing but V square M upon 2R. So half will become V square M upon 4R. Therefore, that is why I have already told you that this omega 1 and omega 2 are called half prop frequencies. Now, this is a simple numerical. You can solve it. Resonance frequency, you have to calculate it. Given R, L, and C. Okay. Then you have to calculate the half of where R is 2 ohm, L is 1 millihenry, and C is 0.4 microfarad. So you can easily calculate it. Omega naught is nothing but 1 upon under root LC. Substitute the value of L is equal to 1 into 10 to the power minus 3, and C is equal to 0.4 into 10 to the power minus 6. Micro, this symbol is of the micro-minded. Those who don't know, this M represent milli, that is 10 raised to power minus 3, and this is micro is 10 raised to power minus 6. It can be, if it is N, okay, it represents 10 raised to power minus 9 nano. Okay. And if it is PF, then what it represent? Can anybody can tell me in the chat box what this P represent? Not 10 raised to power 12, it is 10 raised to power minus 12. Okay. So it is 10 raised to power minus 12. Okay, picofarad is known as picofarad. So be cautious about these two numerical values. Half power frequency, you can easily find out, okay, by the given formula. Bandwidth is nothing but W2 minus W1, and the amplitude of current at omega naught, omega 1, and omega 2. Okay, so by half power frequency, you can find out the half power, then you can find out the corresponding value of the this amplitude of current. So another question is, this is the value of C that will produce. So another question, the same question, that R is 4 ohm and L is equal to 25. A series connected circuit, R is 4 ohm and L is calculate value of C that will produce a quality factor of 50. Okay. So this you have to do it because we know that the quality factor is defined as omega naught upon beta. Okay. So we want a quality factor is of 50, and omega is nothing but 1 upon root LC. Okay. So, and this bandwidth, oh, sorry. Okay, so by substituting all these values, okay, you can find out the corresponding value of all the C. Then once you find out all this, you can find out omega 1, omega 2, and beta also. Okay. One more thing, that beta is also equal to R upon L. So instead of beta, you will substitute R upon L. So once you calculated, R is given, L is given, so beta is known to you. Okay. let me clear the things, how the things are to be done. First of all, you will calculate beta in this question. Beta is nothing but R by L. So 4 upon 25 into 10 raised to power minus 3. This we have already interpreted. Okay. This we have already calculated. Okay, so you can calculate the beta value. Okay, once you have calculated the beta, now you have calculated the value of C. Now you know that this quality factor Q is equal to, which is given as how much, 50, is nothing but how much, omega naught upon beta. So you have already calculated beta from here, and omega naught is nothing but 1 upon under root LC. L you know, 25 into 10 to the power minus 3. Now you can calculate, just use the your scientific calculator and calculate the value of the C. Once you have calculated C, then you can calculate omega 1 and omega 2. These two formulas I have already given you for an RLC series circuit. And once you have calculated these, all this, you can determine the average power taking Vm is equal to 100 volt. So I think so. These are very easy questions. Just you know the formula, the basic concept, you can easily do it. Now we come to the another phenomena called parallel resonance. Now mind it, we are just taking a case of series and parallel, but resonance can be any circuit which contain R, L, and C in any configuration. What you do, you calculate the internal impedance of the circuit as viewed from the source terminals. Then once find out the impedance, you make the imaginary part is equal to 0. Once you find out the imaginary part is equal to whatever condition you obtain is the condition of the resonance. Okay, so now in this case, this is a parallel circuit is there. Okay, R, L, and C all are three connected in parallel with respect to a source. A source of 10 sine omega t is being applied to it. Now you've been asked to find out what will be the so you need not have to cram it anything. Just what I have told you, find out the impedance as viewed from the source terminal. So open it. R will be R, it will be j omega L, and this will be 1 upon j omega C. Okay, so all these three are in parallel. So we find out the admittance. So admittance is nothing but y1 plus y2 plus y3. What is the admittance of R? It is 1 upon R. What is the admittance of inductance j omega L? It is 1 upon j omega L. And what is the admittance of the capacitance of value minus j upon omega C? It is nothing but 1 upon minus j upon omega C. You just substitute this value as shown in the figure. The slide is in front of you. No, Q factor is in fact Q factor in fact represent how sharp the curve is. Sharpness. Sharpness means how pointed. It is given like this. You can see, imagine this is sharp. If I will expand it, okay, this is not sharp because something a flat band is being there on the resonance point. Okay, but I will, if I reduce it, it will become more and more sharp. The peak point will become sharp. Sharp means तीखा. ठीक है, तीखी मिर्ची नहीं होती है, लाल मिर्च. ठीक है. So that is why quality factor, high quality factor means curve will be sharp. So you just now tell something. Somebody has asked the question. I have replying that question. Now, once you find out the total admittance. You just find out it 1 upon R plus j omega C minus 1 upon omega L. Now, as I've already told you, you can apply either to the impedance or to the admittance as per your convenience. The theory will remain same. So theory says that in order to resonance to occur, the imaginary part should be 0. The imaginary part 0 means omega C minus 1 upon omega L should be equal to 0. This is the imaginary part of this parallel resonant circuit. This, okay. So you will find omega C is equal to 1 upon omega L. Okay. When you solve it, you will find omega is equal to 1 upon under root LC. To a surprise for you that the results are coming to be same. Okay, you need not have to get surprised, but now the value of the current and voltage will be different. Okay, here you will find that the admittance is 1 upon R. At resonance, the impedance consists of only conductance Z, that in series it was R. The value of current will be minimum since the total admittance is minimum. Okay, the admittance is minimum and therefore the current will be minimum. In case of a series as well, it was maximum. So don't get infer from the current value or the voltage value. Okay, the voltage and the current are in phase. Definitely, imaginary part is 0. So voltage and current definitely they are in they will be in phase. Now you can find out what is the resonance frequency. I have already told you omega naught is equal to 1 upon LC, or in terms of F, it will be F naught is equal to 1 upon 2 pi under root LC radian per, hertz. In case of F, it is hertz. In case of omega naught, it is radian per second. Now, you can also calculate the half power frequency. In this case, the half power frequency, same methodology you have to adopt. What is the value of the current? Then what is the value of the current at the maximum power? Okay, and you make the current as 1 upon root 2, calculate it, you will find it omega 1 is equal to 1 upon minus 1 upon 2 RC plus under root 1 upon 2 RC whole square plus 1 upon LC. Okay, and then another is the same, only there is change of the sign. Here it is minus, here it is plus. So these are the two, omega 1 and omega 2. When you will solve it, you will find that the bandwidth will comes out to be somewhat like this. It will come out to be 1 upon RC, that is omega 2 minus omega 1. And when you will find out the quality factor, that is omega over beta, it comes out to be omega naught RC. So you find that in case of the in series circuit, the quality factor was dependent upon R and L. The quality factor was dependent on R and L. But in case of the parallel circuit, it is dependent upon R and C. This is clear from the, no doubt, the resonance frequency also plays role, but two parameter R and C are also playing an important role. Okay, so in order to increase the quality of a parallel circuit, parallel RLC circuit, what you do, you increase the resistance and you increase the capacitance value also. Okay, definitely you will get a sharp curve, okay, sharp resonance. There's one numerical again in front of you, that is R, L, and C are there, where R is 8 kilo ohm, L is 0.2 millihenry, and C is 8 microfarad. You have to calculate omega naught. Omega naught, you can calculate it. It is 1 upon under root LC. Okay, L and C both are given to you. Then you calculate quality factor. Quality factor is nothing but omega naught RC. Omega naught is you have already calculated. R is known to you, that is 8 kilo ohm, and C is 8 microfarad. So do write 8 into 10 to the minus 6 and 8 kilo ohm as 8 into 10 to the power 3. Similarly, calculate omega 1 and omega 2, and also the power dissipated at omega naught, omega by the given formula. So things are very clear. Okay. There is another question. A parallel resonance circuit is there. Okay, on a similar basis, you can practice this problem for your more, in order to grasp the fundamentals in a more way. So now definitely you will ask, where these what is the application of this so-called resonance circuit. The application is in the passive filters. There are two types of filters are there. One is active filter and one is the passive filter. As an electrical engineer, you will come across this filter circuit in the second semester in the circuit theory chapter 2nd. Now this is what is passive and active. Passive again means that no external energy source is being used, only R, L, and C are being used. So passive elements R, L, and C are used in any filter circuit. First of all, what is a filter circuit? Now you know that you are generating the electricity at 50 hertz in India and other European countries, while in USA you are generating at 60 hertz. So you always want that at your home the 50 hertz frequency should come. Now suppose a signal is coming to you, electrical signal waveform is coming to your home with not only 50 hertz, with 100 hertz, with 150 hertz, then 200 hertz. Then these all 50, 100, 200 hertz waveform signals are undesirable, So what you will do, you will provide an electrical filter in front of me, so that 100, 150, 200, they get eliminated and I should get only 50 hertz. Just as you used to do filtering at your home for your to have a clean drinking water. You are getting water from PhD, okay, and through your tape, then you put an so-called a filter over the bucket, okay, and then all the dust or material, something contamination is there in the water, get filtered out through that filter, that is cloth filter or plastic filter or whatever may be, and then you drink a pure water. Similarly, here in electrical also, we want to remove the unwanted signal. Okay, so in that case, we use the filters, and that filters are being designed using R, L, and C. So once R, L, and C are there, definitely they will have a resonance phenomena. Hence, that resonance phenomena, how it is going to affect our performance. So you should know the analysis of the resonance phenomena. So they can be used in low pass filter, high pass filter, band pass filter, band stop filter. What are these filters that we will use in our so-called the circuit, sorry, second chapter. But suppose a band pass filter is there. Now band pass ideally means it passes a particular band of frequency, but in that if resonance is happening, okay, then how to accommodate that resonance frequency, that is also we have to take into account. Okay, so this is just an arithmetic I have shown you, though it is of not of use, but for your convenience, you can say that yes, these filters are being, these sorry, resonance circuits are useful in the analysis of the so-called the filters. Okay, and the filters are nothing but they are meant for removing the unwanted signal from the given signal. So that's all about the resonance circuit. You practice more and more numericals. In fact, any circuit given in any configuration. For example, this circuit. Okay, there are L are in parallel, while with this parallel combination, the resistor is there. Now, suppose I ask you find out the resonance frequency. What you will do? You will just remove this source and find out what is the internal ampere. These are two in parallel, and this parallel combination is in series with it. This R. Find out this. Okay, and then again equate imaginary part to zero of that given impedance. Okay, then you will get a condition for the resonance, and that condition of resonance, unfortunately in this also case, the fortunately in this case also omega naught comes out to be 1 upon LC. So this is an example of band stop filter. Okay, then similarly you can find out omega 1 and omega 2 at half. These are nothing but half power frequency, and then you can find out bandwidth and ultimately the quality factor omega naught upon beta. So all these things can be found out for any circuit containing R, L, and C in any configuration. You can find out resonance frequency, you can find out its bandwidth, you can find out its quality factor. So these three important parameters you can easily find out for any circuit which contain R, L, and C. So that's all for today. If any doubt, please ask in the question in the chat box. Any question, please write in the chat box. Divyar, no doubt. Okay, fine. Chittoda or anything is being there, please write down in the chat box. Oh, people are more interested in the midterm syllabus. Yeah, definitely. Unit 1 and Unit 2. Yeah, Unit 1 and Unit 2 will be in your course, no doubt. Okay, yes, definitely. Are you comfortable with the Unit 1 and Unit 2? Are you comfortable? Mock test, it will be, I think, the Google through Google form. As far as I am concerned, a time limit will be fixed. Okay, so time in the fix means not only the duration but also at what time it will start. It will probably start with a particular time. 1 hour will be the duration. Okay, and after 1 hour, the Google form will not accept any response. So it will be completely in a systematic and scientific manner. Yes. Mock test, Garvesh, can you explain me just what do you mean by mock test? Any practice test you want? You can just open your mic and just speak out. What do you want to say, Garvesh? Garvesh, I have muted you off. Can you tell me what you want by the mock test you want and practice test, or what do you want? The mic is on. Garvesh, the speaker is on. Probably I'm not getting your voice. I don't know what is the reason. Anybody has want to say, then please can. I want to see just. How many participants? 21 participants are there. Anybody want to speak anything? Then please mute yourself. Unmute yourself. Any doubt? Probably it may happen that many of them are active or not. I am speaking so much. Yes. Keshav Sharma, do you have any problem? Keshav, I have muted you off. Any doubt?
No, sir.
Keshav? No doubt. Okay, fine. Himanshu Dosia, I have
No,
muted
sir.
you off. No doubt. Divyarth, you have already mentioned no doubt.
सर ये ऑब्जेक्टिव क्वेश्चन की प्रैक्टिस कौन सी बुक से करें?
देखो प्रैक्टिस तो अब यूं है कि मेरे पास तो ऐसी कोई बुक है नहीं, लेकिन मैं तुम्हें कुछ क्वेश्चन दूंगा एग्जाम शुरू होने से पहले. इज इट क्लियर? पीडीएफ फॉर्म में. ठीक है, मुझे थोड़ा याद दिला देना तो तुम्हारे सारे कंसेप्ट क्लियर हो जाएंगे उससे.
ओके ओके सर.
Anybody more who want to say anything? Today I am giving you freedom that you have a choice to talk with me. Okay. Otherwise, in the routine day, what happens if I give choice to that, it will create a nuisance. So, if anybody want to say today, then please tell me. No one? No one interested to talk? Okay, fine. Then I should stop the meeting. Okay, thank you very much.